due to any point charge capital Q at distance r on point P is equal to force experienced by unit positive charge when kept at P. At P. Okay, so what is electric field? You can say if you want to find electric field at point P due to a point charge, then electric field at point P is equal to force on unit positive charge. Simple. So in your way, in your words, electric field is, you can say electric field is force experienced by +1 coulomb. So in your word, electric field is force experienced by +1 coulomb. If you want to find electric field at a particular point, put there +1 coulomb. Okay, the force on +1 coulomb will be electric field. Agree? It's a vector quantity. It's a vector quantity and its unit is Newton per coulomb or volt per meter. We represent electric field by E. We represent electric field by E. It's a defined term. It's a defined term. Means it will be always equal to force experienced by +1 coulomb. You cannot assume -1 coulomb. No. Because it is defined as force experienced by unit positive charge. So you cannot consider any other charge at the place of +1 coulomb. Okay. So it is this is basics of electric field. So remember definition in your word, electric field at any particular point due to any charge distribution is actually force experienced by unit positive charge. It's a vector quantity. So we represent it by E. Let's talk about formula. Suppose this is a point charge Q and I want to find electric field at point P at a distance r due to this point charge Q. So I will assume a unit positive charge here. I will assume a unit positive charge here and I will find force on this unit positive charge. So the force on unit positive charge is known as electric field and it is represented by E Q1 Q2 divided by 4 pi epsilon naught r, and at the place of constant I can write K. So remember formula, KQ by square of distance. So what is electric field? KQ by square of distance, and its direction will be equal to the force on unit positive charge. So this is the direction. This arrow represents direction. Okay, so this is electric field due to point charge. Always remember it's a vector quantity. Okay, in vector form, if you want to write the expression of electric field in vector form at point P, let's write electric field in vector form. Electric field in vector form. In our case, let's write it in vector form. So you can write it like this. The direction of electric field is along R, right? Suppose this is direction of R. So the arrow of electric field is along arrow of R. So we can say KQ by R square into R cap. And everyone knows that R cap is equal to R vector divided by magnitude of R. So you can write it like this. Electric field is equal to KQ R vector divided by R power 3. So this is vector form. That's it. Find net electric field at point O due to these 2 point charges. O is midpoint. net electric field at centroid of triangle shown. This is equilateral triangle. Each side is of a length. This is plus q plus q plus q. Find net electric field at the centroid O. Field at center of square are kept at the corners of a square. Your task is to find net electric field at O. This is A, this is A, this is net electric field at center of cube shown. There is a cube. There is a cube like this. This is length of each side of this cube is A plus q plus q plus q plus q plus q. Correct. And O, this is center. Okay. To find electric field at point O, assume a unit positive charge capped at O. Okay. So force on this plus 1 coulomb due to this will be repulsive in this direction, agree? And same force will act in opposite direction. Why same force? Because product of charges both the side is same and distance is also same. So right hand side electric field is kq by a square and left hand side electric field is kq by a square. So net electric field is 0. So if you talk about net electric field, it is 0. Okay, but if you try to find net electric field here, you'll have to assume unit positive charge at O. So this unit positive charge will experience a repulsive force downward. Okay, how much? See, k q upon square of distance, है ना? So this distance is a by root 3, everyone knows. Okay, a by root 3 whole square, so you got 3kq by a square. This is the electric field downward, and let's suppose this is E. Same magnitude of electric field will act in this direction along line of joining away, agree? And same amount of electric field will act in this direction along line of joining away, like this. This is also E. Okay, this angle is 120 degree. I think everyone knows this angle is 120 degree. So resultant of these two E will be E upward. Hana, this is fifth question like this. We solved 5 more question like this already. So please remember, revise your copy. Okay, it is already there in your copy. If two equal vectors are at an angle of 120 degree, then resultant will be E upward, and this E will get cancelled. So E net is again 0. Okay, now let's talk about this case. Assume unit positive charge at the center, right? This will repel this side like this. These two will get cancelled, and electric field of these two will get cancelled. So again net electric field is 0. If you talk about net electric field, 0, because these two will cancel each other's electric field and these two will cancel each other electric field. In the same way here also, electric field of each and every charge will get cancelled by each other. Okay, this is a cube. Okay, it is not looking like a cube, but it is actually a cube. You can see out of 8, 7 charges are positive and only 1 charge is negative. See this, charge at 6 is negative q. Okay, to find electric field at point P, assume plus unit positive charge at point O. Okay, so electric field of charge present at 4 and charge present at 7 will get cancelled by each other, right? Because 4 and 7 are at the opposite side of body diagonal. Okay, so charge 4 and 7 will cancel their electric field, right? So 4 and 7 going to cancel each other's electric field. Agree? In the same way, 3 and 8 will cancel their electric field. Agree? Yes or no? Please tell me. Okay. Now 5 and 2 will also cancel. So in same way, 5, 2 and 3 and 8 will cancel their electric field because they will repel positive charge in the opposite side. But 1 and 6 will not cancel their electric field. In fact, their electric field will get added because 1 is repelling +1 along 6, and 6 is not repelling along 1. 6 is attracting +1 coulomb along itself, right? Only electric field of 1 and 6 is in same direction, right? Only electric field of 1 and 6 is in same direction. So E net at O is equal to electric field due to 1 plus electric field due to 6. Now what is electric field due to 1? KQ upon square of distance. So distance is A by root 3 A by 2. Agree or not? Length of diagonal is A root 3. But distance between 1 and O is half of A root 3. Agree? O is center. The length of complete body diagonal is root 3A. But point O is at this center. That's why the distance must be this. Plus KQ upon root 3A by 2 whole square. Agree? So what is net electric field? What is net electric field? Net electric field at O is equal to 2KQ by 3A square by 4. It will go up. So 8KQ by 3A square. This is net electric field at O. Okay, copy. Please ask if you have any doubt. This is a regular hexagon, means all the sides are same. You can see 5-point charges are there, but at this point there is no charge. Okay, at this vertex there is no charge. Now your task is to find net electric field at O. So assume a unit positive charge at O. Now electric field at O, because of this charge, will be in this direction, and because of this charge in opposite direction. Because of this charge will be like this, and electric field due to this charge will be in this direction. So electric field these two will cancel their electric field, and these two will cancel their electric field, right? So at point O, the electric field is only due to this charge, right? And always remember the distance between center and vertex of a regular hexagon is equal to A, is equal to length of sides. This is also A. Okay, so these two will cancel their electric fields. These two will cancel their electric field. So at point O, electric field is due to only this plus Q, and it will be repulsive, right? So electric field, net electric field at center will be equal to KQ upon square of distance. That's it. That's it. Because only electric field only due to this charge is present, right? Okay. Like this charge distribution is there till infinite. Consider a plus charge Q at 1 meter, another charge Q at 2 meter, another charge Q at 4 meter, another charge Q at 8 meter, and the task is to find net electric field at O. Okay, so this plus Q will apply electric field in this direction. The other plus Q will also apply electric field in this direction. Other plus Q will also apply electric field in the same direction. So if you talk about net electric field at O, net electric field at O, is E1 plus E2 plus E3 plus so on till infinite, right? What is value of E1? KQ by 1 square. What is E2? KQ by 2 square. What is E3? KQ by 4 square. KQ by 8 square. So on. Take KQ common. What you will get? 1 by 1 plus 1 by 4 plus 1 by 16 plus 1 by 64. Dash till infinite. So it's a GP, right? And the common ratio is 1 by 4. You multiply this by 1 by 4, you get this. Multiply by 1 by 4 in this, you will get this. Multiply by 1 by 4 in this, you will get this. So it's a GP. It's a GP. And we want to find net electric field at O. Right? How to solve this GP? What is the answer of sum of infinite terms of a GP is A upon 1 minus R. Where R is 1 by 4 and A is first term, it is 1. So 1 minus 1 by 4. You'll get 4 by 3. So sum of this thing is 4 by 3. So net electric field at O is equal to KQ into 4 by 3. Copy. And opposite polarity. Okay, dipole is a system of two charges of equal magnitude and opposite polarity placed very close to each other. Placed very close to each other. This is called a dipole. So suppose you have a minus q charge and a plus q charge kept at distance, suppose 2a. Let's assume this distance is 2a. So this system known as electric dipole. This system is known as electric dipole. Okay. Now we need to define another thing, another important parameter, that is electric dipole moment. What is electric dipole moment? Electric dipole moment. What is electric dipole moment? So the answer is electric dipole moment is a defined term. Electric dipole moment is a defined term which is equal to product of any one charge, dipole, and distance between them. So it is a defined term which is equal to product of any one charge of dipole and distance between them. It's a vector quantity, okay, and we represent it by P. We represent it by P. So P is equal to Q into 2A. From this diagram, any one charge is Q and the distance between charges is 2A. And I told you it is equal to any one charge into distance between them, and as I said, it's a vector quantity. It's a vector quantity. So it must have direction, right? So its direction is from negative to positive charge. Always remember the direction of dipole moment is from negative to positive charge. Okay. So this is how we represent our electric dipole moment. Copy. See, the question is find net electric field at point A. Point A is at distance r from center of the dipole. This is dipole, and P is electric dipole moment, where P is equal to any charge into distance between them, and its direction is from negative charge to positive charge. Our task is to find net electric field at A. So we are assuming unit positive charge at A. Actually, in reality, there is no unit positive charge at A. We are just assuming there is a unit positive charge at A. Now to find net electric field at A, first we will find electric field at A due to plus charge. So due to plus charge, what is distance between plus Q and 1 coulomb? This complete distance is R. This is 2A. So how much distance you must subtract from R to get this distance? What is this distance? This is R minus A, because this complete is 2A, so this much is A and this is also A. Agree? So the distance between plus Q and plus 1 is R minus A. Okay, so plus and plus will repel each other. So positive electric field due to plus Q is away like this. Okay, and what is electric field? KQ upon square of distance. So K small q upon square of distance, this distance, R minus A whole square. So it is right hand side. Okay, now can you suggest me the direction of electric field due to negative charge? Can you suggest me the direction of electric field at A due to negative charge? Right or left? Negative charge is going to attract plus 1 coulomb, right? So the direction of electric field due to negative charge is going to be left. And I made a small arrow because of E negative. I made a small arrow. Why? Why I made a small arrow? I made big arrow for E plus, but I made a small arrow for E minus. Why? Okay, because distance is big, that's why E negative will be small in the magnitude, and the value of E negative can be written as KQ upon square of distance, and the distance is R plus A whole square, right? So if you talk about net electric field, what is net electric field? E plus minus E minus. Agree? I will subtract a smaller electric field from bigger electric field to get net electric field. Why I am subtracting? Because they are opposite in direction. Like this you will get net electric field. Put values KQ upon R minus A whole square minus KQ upon R plus A whole square. Solve this, you will get answer. You will get E net as, take KQ common, 1 upon R minus A whole square minus 1 upon R plus A whole square. Take LCM, be careful with calculation. Everyone look at the board. R minus A whole square into R plus A whole square. This into this, cross product, minus R minus A whole square. Solve this. Solve this, and here we can write KQ bracket R square plus A square plus 2AR minus R square plus A square minus 2AR bracket closed. In denominator we can write R minus A into R plus A whole square. Agree? Everyone understood till this? Any doubt in the calculation till this? So after this, let's bring this minus sign into the bracket. So R square will get cancelled, A square will get cancelled, minus will come plus, 2AR will come 4AR. So you can write like this, E net is equal to KQ. Here you can write 4AR, and in denominator you can write R square minus A square whole square. Because this is A minus X minus Y into X plus Y. So it is a formula X square minus Y square. We applied that formula. Okay. So you got E net as KQ 4AR divided by R square minus A square whole square. Now we know that P is equal to Q into 2A. I already told you this. Look at this. So Q into 2A. See, you have Q into 4A. So out of this you can write it like this, 2QA into 2R. Like this you can write. So E net will become like this, 2KPR upon R square minus A square. Now I told you it is dipole when the charges are kept very close. Means if A is very smaller than R, then we can write R square minus A square approximately equal to R square, right? So what we will get? E net is equal to 2KPR upon R power 4. 1R will get cancelled. Final result 2KP by R cube. So this is final result. Copy.